Welcome to this Maths Made Easy video on independence. And to start with, let's take a look at mutually exclusive events. So we say two events, A and B, are mutually exclusive if they can't both occur at the same time. So in that case, if we have the two events A and B here, then we can write the probability of the intersection of these two events, so A intersection B, is equal to 0 here. Okay. We also know if A and B are mutually exclusive, then the probability of A or B is the sum of the probabilities of the individual events. So we could write that here as the probability of A union B is equal to the probability of A plus the probability of B there. Okay, so that's the basic ideas there of mutually exclusive events, and we need to be familiar with both of these ideas. Moving on now to independent events. So say we have two events A and B which are independent, then the outcome of event A would not affect the outcome of event B and vice versa, so they do not affect each other. Now if we write down the events here, so A and B, what we can say then is the probability of A given B is simply the probability of A. Okay, so this is if A and B are independent. Okay, so A and B are independent. We can also say here the probability of B given A would simply be the probability of B here. And finally, the way we test for independence here is if the probability of A intersection B is equal to the probability of A times probability of B here. This is the most frequent way you will see this in exam questions. We will also see an example of this in our examples. And finally, we move to modelling assumptions. Now, most probability models have made several assumptions in order for these models to be practical to be used. So for example, when you roll a die, you may assume that each number is equally likely. However, in reality, the die could be biased or could have a small probability of landing on its edge. Now, some common assumptions that we may make in our probability models. So for example, our first assumption here might be equally likely events. So if we just jot this down here. So equally likely events. So what do we mean by this assumption? Well, what we're saying here is, could there be other low probability outcomes? In that case, would they be significant enough to render the model redundant? Okay, so that's the first assumption we could make here. We might also make an assumption here based on past data. So we're modelling here based on past data. We jot this down here as well. So in this case here, what we're asking is, can we trust the data? How was it sampled? And is it relevant to what we're actually doing? So that's another assumption we could use in our probability models. And finally, another example of an assumption here that we may use in our probability models is the idea of randomness. So randomness. So here, we're asking ourselves, is the outcome genuinely random? Have we done something that could have affected the outcome without us knowing? So like we can see, all these assumptions may be used in our probability models to make sure that the model can be used practically. And that concludes this Maths Made Easy video on independence.